All right, so this is chapter 7, section 4, part 2. We kind of left off here, right, where it said write the matrix in row echelon form. So how do I know it's in row echelon form? Diagonals of ones and zeros where? Below, only below, right? If it was reduced row echelon, then it's above and below. So the first thing I'm going to do here is rewrite this into a matrix. So 2, -8, 8, -2, 1, -3, 1, 4, -6, 3, -15, and 9. Be so very careful when you're rewriting it, because I see sometimes you lose the negative off the first rewrite and then it's wrong the entire way after that. So you got to be so careful. This is like, again, one of those processes. Go slow to go fast. Go slow and careful the first time and you won't have to redo it again. Okay, so my first goal is what? Get the 1 in the top left. What's one way you could do it? Because there's more than one. Okay, perfect. You both said the same thing. Or not the same thing, but both options. Switch row 1 and row 2, or multiply row 1 by a half. Do either one. I'm going to switch it. I tend to like to switch if I can. But I would only say it's the same because only all the numbers in the top row are even. If all the numbers in the top row are not even, and when I multiply by a half, I end up with a fraction, I would definitely avoid that step. Not to say you're never going to get fractions as you build, but you want to avoid them as long as you possibly can. Adam.
Did you change the part 2 notes?
Did I change? So this is obviously, so I'm going to switch row 1 and row 2. So 1, -3, 1, 4 goes in the top, 2, 2, -8, 8, -2, and the last one, -6, 3, -15, 9. All right, so my next goal is what? Get a 0 where this 2 is. And how do I do that? Good. -2, row 1 plus row 2. You could have also multiplied row 2 by 3 and added it to row 3. That's an option this time, okay? So I'm going to multiply everything in the top by -2. -2 goes to 1. Goes to -3, that's 6. Goes to 1, that's -2. Goes to 4, that's -8. And I'm adding it to row 2. I get 0, -2, 6, -10. And again, we can replace either row 1 or row 2 with that. Whichever 2 you're involving in the adding, you can replace. But I wanted row 1 as it was. I was working to replace row 2, so that's what I'm going to replace. What's my next goal? You can do that. So yesterday I told you get the zeros before you get the ones. There are times when it's easy to get the 1 and you could totally get it then. You just don't want to get the 1 before you get all the zeros in the row. So let's say, for example, I get this 0 and this is not a 0 yet. I'm not going to waste my time getting that 1 because when I get this 0, it's going to change it. But I only need 1 0 in row 2 for row echelon. So I can actually easily get the 1 right now. You don't have to, but you can. If you don't get, well, it doesn't matter. If you went straight for the -6, you could multiply row 1 by 6 and then add it to row 3. That's an option here. So it's like choose your own adventure. That's an option here. Or do the -1/2 here. So -1/2 is going to get that -2 to become a 1. So if I did the notation on that, it would be -1/2 row 2. So I'm just going to rewrite row 1, and then I'm going to multiply row 2 by -1/2. So this is 0, that's 1, that's -3, that's +5. And then row 3 stays the same, -6, 3, -15, 9. Good morning, Anna. Okay, now I can get the 0 here. So I want to do the same thing. +6 times row 1 plus row 3. And I get 6, -18, 6, 24, and I'm going to add it to row 3. -6, 3, -15, 9. I get 0, -15, -9, 33. That replaces row 3. I'm going to come back up to the top up here. So 1, negative 3, 1, 4 is row 1. Row 2, 0, 1, negative 3, 5. Row 3 is now 0, negative 15, negative 9, 33. Now where do I go? What do I want to do?
Couldn't you multiply the bottom one by a third?
You could, sure, make it smaller numbers. Sure, but you don't need to, right? Yeah.
Could you multiply the second row by 15 and then add the second and third row?
Yep, so both of those options are right. If you did 1/3, it does make it smaller numbers. It would be 0, negative 5, negative 3, and 11. And then you only have to multiply row 2 by 5. But again, I would only do that if they all divide evenly. Like, because they're all multiples of 3, I would say to do that. If they weren't, don't. I want to get a 0 here. So I'm going to do the 15 times row 2 plus row 3. So I'd get 0, 15, negative 45, and 75. And I'm going to add it to row 3. 0, negative 15, negative 9, and 33. 0, 0, negative 54, and 108. And that replaces row 3. 1, negative 3, 1, 4, 0, 1, negative 3, 5, 0, 0, negative 54, and 108. And then my last step is what?
You can multiply the top by, oh wait, no, never mind.
Yeah, because then you're going to lose your zeros. So when you go to get your 1s, remember, just do the reciprocals. Like, that's a big number, but it's going to cancel out. So if I multiply R3 by negative 1 over 54, I'd get, well, I'm going to rewrite the first one. 1, negative 3, 1, 4, 0, 1, negative 3, 5, 0, 0, 1, negative 2. So just like on your quiz, you'll have a scientific calculator for these if you end up with big numbers. So like if you can divide them, make them smaller like Ethan was recommending, that's totally fine. If not, like if you're unsure 108, does 54 go into 108, you have your calculator, do the quick check. So this is row echelon form, and that was the goal for this question. When we get finished with today, we will then take this into its triangle system and we will solve it, and the overall goal is to solve the system. So you end up with an X, Y, Z. So my advice is, obviously for your test, that's a question. Not like any of the process along the way, but all the way to the end goal to get to the end. When you go to solve a question like this on your test and you get the first one, like that first whole number or the first solved variable would be z equals negative 2. If that's something crazy and weird, obviously you know you did something wrong. Go back and check it. Because I'm not going to give you anything that's like 117 over 3. If you get like a half, maybe, but like not anything ridiculous, okay? And then you would want to go back. And that's why your notation has to be there. That's why you're telling not only me but you what you did in each step. That's why you're writing out each step. Like every year I get a kid that's just like one of those that's smart but super lazy and doesn't want to have to write out the work. I get it, you're smart. You don't have to prove it to me. But you mess up and you don't show me work, this is like a big chunk of points gone. So you want to make sure you're showing that work. Questions so far? Okay, so now we're building on it. So why are we doing this? We did this a little bit yesterday, but if it said write the solution represented by the augmented matrix, this is in reduced row echelon form. What would my first row be? X is equal to negative 3, and second row, y is equal to 5. So if I have it in reduced row echelon, which is this one, I can go straight to my solution. It would be negative 3, 5. That's the payoff of reduced row echelon. The harder part is you got to get 3 more zeros on your actual matrix. But then you go straight to your answer. So this is the first method, which is called Gaussian elimination with back substitution. Okay? All this is you're going to take your matrix, you're going to get it into row echelon form like we just did on the first example, And then we're going to write the system of linear equations, and it will be a triangle system. You will have one with 3 variables, one with 2 variables, one with 1 variable. And then you're going to use back substitution, which means work your way up. The one with 1 variable you solve, take that, plug it into the one with 2 variables, and take those and plug it into the one with 1 variables. So you're kind of just piecing together the things that we've been doing. The row echelon form and then the triangle system goes together, okay? But the name of this is Gaussian elimination with back substitution. So if and it will, like the test is going to say, take this system and solve it using Gaussian elimination with back substitution. And that's what it means. And then the second method is called Gauss-Jordan, which is the reduced row echelon. All right, so we're going to do it with a 2 variable first. So as soon as I see Gaussian elimination, I know that this means row echelon form, not reduced, but row. I need the diagonal of 1s with the 0s below. So I'm going to rewrite that in its matrix, 1, 2, 7, 2, 1, 8. I already have the 1 in the top left. If these were switched, that'd be the first thing I would do is switch them, okay? So I just want to get the 0 here. How could I do that? But good. -2, row 1 plus row 2. So I'm doing -2 times 1, -2 times 2, -4 times 7, -14 plus row 2, 2, 1, 8. I get 0, -3, -6. That replaces row 2, right? Row 1 was fine. Row 2 is what I want to replace. And then the last thing I need to get is what? Good.
Multiply the top. No, you just do 1 over 3.
Good. -1/3 times row 2. So the top one stays the same. 1, 2, 7. The second one becomes 0, 1, 2. Now I'm in row echelon form. From here, I write it in matrix form, in equation form. X plus 2y equals 7, and y equals 2. And then I use back substitution to plug in the y. And x equals 3. So my answer is 3, 2. So this is like I said yesterday, you have graphing, you have elimination, you have a substitution, and now you have Gaussian elimination with back substitution, the 4th method to solving a system. All right, now we do the 3 variables. So first step is rewrite your matrix. Rewrite it in matrix form. 3, -2, 1, 15. -1, 1, 2, -10. 1, -1, -4, and 14. All right, first goal. Good. So I want 1 up here. I'm going to switch row 1 and row 3. I would not want to multiply the top by a 1/3 this time because that 2 is going to get yucky. The 1's going to get yucky. I don't want to work with fractions if I don't have to. So I'm going to swap it. So 1, -1, -4, 14. -1, 1, 2, -10, and then 3, -2, 1, and 15. Next goal.
Add row 1 and row 2.
What are you trying to do?
With the 0.
Good. 0 where the -1 is. So row 1 plus row 2. 1, -1, -4, 14, -1, 1, 2, -10. And I get 0, 0, -2, and 4. That can replace row 1 or row 2, but we liked row 1 the way it was, so I'm replacing row 2. So now what happened that time? I got 2 zeros. I only need 1 0 in that row. Where do I need 2 zeros? In the bottom. So what could I do with that? Switch row 2 and row 3. So 1, -1, -4, 14, 3, -2, 1, 15, 0, 0, -2, 4. Now I'm back to where I was before. I need a 0 where the 3 is. How do I get it?
Multiply this out by -3.
Good. -3, row 1 plus row 2. -3, 3, 12, -42. Add it to 3, -2, 1, and 15. 0, 1, 13, -27. Rewrite row 2. Now what?
Multiply the by 13 multiply the top. Multiply row 3 by 13 multiply the top by 2.
But I don't need to get a 0 there, right? What I need here is a 1.
Multiply the bottom by -1/2.
Good. -1/2 row 3. Now comes my system. X minus y minus 4z equals 14. Y plus 13z equals -27. And z equals -2. So already I have my z. I'm going to take that, plug it into the second one in place of the z. Add the 26. Y equals -1. There's the second one. And then we take and plug in both. The z and the y. X minus a -1 becomes +1. -4 times -2, +8. X plus 9 equals 14, and x equals 5. And there's the last one. So 5, -1, -2 is the solution to this system. So by the end of this chapter, you're actually going to learn like we're going to do Gauss-Jordan. So you'll end up having 4 options for solving a systems of equation with 3 variables and 3 equations. Honestly, if you had the choice, I would probably say the new 1 and new 2 is the easiest. But on this kind of question, it's going to force the matrix part. So the directions would say solve using Gaussian elimination, God bless you, with back substitution. I cannot stress enough to be super careful. This is one of those lessons that I get super proud of you guys at the end, because it's not easy. You work through it, and then your test, I can tell who's worked hard and done it over and over again and knows it so well, and then those that have not practiced it at all and are trying to wing it, which it doesn't normally go well, okay? But even those that work hard and know what they're doing, one missed negative, the whole thing, right? So you got to be really, really careful. Or things like 3 plus 2 is 6. Stuff like that happens on this stuff. Just be careful, okay? And that's why I would always say, if I get to this bottom row and I look at that z and that z is something weird, then I immediately stop and go back and try to figure out where it went wrong. Questions on the process? Yeah. Oh, I haven't even gotten there yet. I think there's 10. I haven't finalized it yet. There will be one Gaussian elimination with back substitution, and then you're going to see a second Gauss-Jordan. It goes a couple of steps further. So I build one into the other. You start it one way and finish it the other way. So you technically get the same question twice, but you're doing 3/4 of the work to get Gaussian elimination, and then you just keep going to do Gauss-Jordan. Yeah, you'll see. Right now. So Gauss-Jordan, you have to put it in reduced row echelon form. Now you're talking the diagonal of zeros, the ones above and below. So we got to work to get 3 more zeros here, but once we do that, there's no back substitution part. So on your test, you're going to get one system with 3 variables that says solve it using Gaussian elimination with back substitution, and you'll do that. And then it will literally say take your ending matrix from that, rewrite it for the next question, and then finish it using Gauss-Jordan. So it's the same question. You should get the same answers. You just have to get 3 more zeros. So you got to keep going. That's the difference.
If you get the first one wrong.
There's partial credit. Like, I don't totally tank you, but yeah, you got to at least know the process.
When is the test?
Next Wednesday. Yep. All right, so again, now we're doing diagonal of ones, zeros below, and the zeros up. And then these would all be the other numbers. So we got to get 3 more zeros than what we just did. The order in which you get those, I tend to like, just like a pattern, so I like to go up and left, but sometimes it works differently. It's not like you have to go in a specific order. All right, so we're going to do, again, 2 system, and then we'll switch to the 3 system. So we start by rewriting. -2, 6, -22, 1, 2, -9. Everything at the beginning is the same as it was. So what's my first goal? Put the 1 at the top. So I'm going to switch row 1 and row 2. 1, 2, -9, -2, 6, -22. Then what?
Multiply the top by 2.
Good. 2 row 1 plus row 2 because I want to get the 0 here. So 2 times 1, 2 times 2, 2 times -9, plus -2, 6, -22. 0, 10, -40. Replacing row 2. So 1, 2, -9, 0, 10, -40. Now here's where you sort of have a choice. Is I could get the 1 where the 10 is, or I could get the 0 where the 2 is. The order in which I do that doesn't matter. Sometimes it makes more sense to get the 1 because it's easy. Sometimes it makes more sense to get the 0 because you have to multiply 2 things to change it. Like this time 2 goes into 10, so it's easy. If I reduce that, it's not a big deal. Sometimes that 2 is not going to be something that goes into the 10, and it'd be easier to get the 1 and then get the 0. But the order here doesn't matter. Like, if I wanted to get the 1, what's my step? This one. 1/10. 1/10, row 2. If I wanted to get the 0, then what would have been my step?
-1 over 5.
Oh, don't complicate it. Do the other way. Do the other way. You're right, it will work, but you could also change the 2, right? Yeah, so row 1 times -5 and add it to row 2. I could have done either of those steps right now, okay? So 1, 2, -10, 0, 1, -4. I got the 1. Now I want the 0 here. So I'm going to do -2, row 2 plus row 1. 0, -2, 8, 1, 2, -9. 1, 0, -1. And that replaces row 1. So 1, 0, -1, 0, 1, -4. And now we've eliminated the back substitution part. I go straight to x equals -1 and y equals -4. All right, rewriting. 3, -2, 1, 15, -1, 1, 2, -10, 1, -1, -4, 14. Probably the most important step, because if you do that wrong, everything after this is wrong, right? 1 lost negative on that, and you've just set yourself up for failure. All right, step 1.
First and the third.
Good. Row 1 and row 3, I would switch. So 1, -1, -4, 14, -1, 1, 2, -10, and then 3, -2, 1, and 15 goes to the bottom. Step 2.
Add row 1 and row
Good. Add row 1 and row 2. And this is where people think they're smart and they just add them and they do it in their head and they try to replace and then they mess it up. So I know it's tedious and I know it's ridiculous, but we're going to write it out. 0, 0, negative 2, 4. Look familiar? It happened again. Look at your first example. This is negative. I finished, I wrote one, the start of one and the second, okay? I have 2 zeros again, so I'm going to do what? Switch row 2 and row 3. 1, negative 4, 14, 3, negative 2, 1, 15, 0, 0, negative 2, 4. Now what?
I multiply the first row by -3 and add it to the second row.
Good. So if you got to this point, let's say, so we already have this system to row, this is the same, that's why I said look familiar. It's the same one we already did to row echelon form, right? If we wanted to keep going in that pattern, we could get the one where the negative 2 is. You can also start to get the other zeros before you get that 1. So the order there doesn't matter. I could work my way up if it made sense. If like this number went into this number, I could easily cancel those out to get the 0. This number goes into this number. Maybe it's easy to cancel those out to get the 0 before you get the 1. You don't have to get the 1 first. The easiest part about getting the 1 in the bottom is it will always be a factor of the other two. You can always change 1 to become something that's the opposite. So I would keep going and I would do the negative 1/2 so that you get 1, negative 1, negative 4, 14, 0, 1, 13, negative 27, 0, 0, 1, negative 2. So when we did row echelon, we were done with this, but we're obviously doing reduced row echelon because it's Gauss shortened, so we got to keep going. So in what order you do the zeros doesn't really matter. Like I said before, I tend to try to do a pattern, so I tend to work my way up. So if I want to get a 0 where that 13 is, can I know it's not pretty numbers, but can I do row 1 and row 2 to get that change? I know you could do, and I would recommend doing row 3, but can I do row 1 and row 2? What would happen to this 0 if I add something to it? I lose it. So when you do this spot, you got to do row 2 and row 3. So remember, like yesterday, we wrote out like on the other side, when we get those zeros, there's a certain order you want to use. It's the same here. To get row 2, column 3's 0, you have to use row 2 and row 3. So I would multiply row 3 by what? Negative 13, row 3 plus row 2. And you get 0, 1, 0, negative 1. That takes the place of row 2. All right, now, again, I need zeros in this spot and in this spot, and the order in which I do them doesn't matter. Yeah. You can add row 2 to row 1, and what are you trying to do there?
Put a 0 and -1.
In this spot, okay? 1, negative 1, negative 4, 14, 0, 1, 0, negative 1. 1, 0, negative 4, 13. That replaces row 1. And the last 0 I need at the -4 spot, you can only use, so like when I do the row 1, 0 here, I can only use row 1 and row 2. When I go for the 0 here, I can only use row 1 and row 3. So there's limitations once you get that far because the rest are zeros. So how do I get that 0? 4, right? 4 row 3 plus row 1. The easy part is usually by the end there's so many zeros, there's not a whole lot of multiplying out you got to do. So 1, 0, 0, 5, 0, 1, 0, -1, 0, 0, 1, -2. And from here, I get x equals 5, y equals -1, and z equals -2, which was the same answer I got using back substitution. Yep.
When did you get the -2 instead of the 4?
When did I get it to be -2?
Yeah.
Up here, I multiplied by -1/2.
Alright.
So if you waited till the end, you would have, like the 1 makes it easy to use it. So I would have done that as soon as I could. Especially because as soon as you get that bottom row, it's your first like indication you're on the right track. If that bottom row ends up being a fraction, then you know you're already wrong. So I would have caught it all the way up here instead of waiting till I get to the end. It would have saved me a lot of time. Questions? Mm-hmm. All right, so this is is how you use your graphing calculator. So there is a button on your calculator that says matrix. It is above the x -1. I go second and I go to matrix. Now the first thing you have to do is under the names column, which is where we're at. See, it says names, math, and edit at the top. Under the names one, you have to create the matrix. In order to do that, so if I click on A, wait, sorry, I have to go to edit. I have to go to edit with the A, and I have to create the matrix. So the little thing at the top is asking me for the dimensions of this matrix. So look to the left of that. After I wrote it in matrix form, what would you say? Are you stuck?
How'd you get to the edit?
If you go, here, let me try something. Start over again. Okay, so I go second and I go to matrix, so second matrix, and then you arrow to the right to get to edit. You can pick any letter you want. Those are all just names of matrices. There's only one we're using, so I'm just gonna go to A. And then I have to build it, so I have to build those little cells doing the dimensions, which is one of the reasons why that's an important question at the beginning of 7-4, right? What are the dimensions of the matrix that we just made? How many rows? 3 rows, how many columns? 4. So 3 by 4. If you reverse it, then when you get this little grid, it's going to look weird. Like you're not going to have enough spaces to do it. So like if you mess up that order, you'll catch it because you won't have enough cells to type your thing in. Now I'm going to write in my matrix. So if I just do 3, enter, it moves to the next cell. So 3, enter, -2, enter, 1, enter, 15, enter. It goes to the next row. -1, enter, 1, enter, 2, enter, -10, enter, 1, -1, -4, 14. So when you look at this matrix, it has to match what we just had written down from the original system. It does, right? Check your signs, make sure they're right. That just entered in the matrix. Now, I go second, quit, and I go back to my regular menu. I go back to the matrix menu, so second, x to the -1 goes back to the matrix menu. Now notice on 1, it has a 3 by 4 there. It's saved my matrix. I go over 1 to math. These are all the things we can do with a matrix, which we'll eventually get to a couple more on this list. But if you scroll all the way down to A and B, it says REF and RREF. So if I go to REF, what do you think I'm going to get? The row echelon, right? So I do REF, and then I have to say what matrix is there. So I go back to second matrix, and I use A. So So if I had more than one matrix in there, this is where I choose which matrix I'm trying to do. Now this may or may not match your row echelon form because remember there's different answers. The bottom row would have to match, but the other ones don't have to match. I get these yucky fractions or decimals in there, right? So I can switch these. If I go to math and I do the arrow fraction, it's going to take all of those numbers and put them in a fraction form. So if I had done row echelon form on that matrix, that is an option I could have gotten. We didn't get those, right? We avoided the fractions. It doesn't mean we're wrong. It just means that's a different row echelon. How do you get what? Did you get the matrix?
Yeah, I have like the grid.
Okay, so now I'm going to go second, back to that matrix menu, and you go to math. Arrow over. And then scroll down, and A and B are REF and RREF. So I would say we very rarely use REF because it's going to give you different answers than what you already got. But RREF, there's only one answer for reduced row echelon. So I do RREF A, and I hit enter, and there's the answer I got, 5, -1, -2. Okay, so tonight is